Hello everyone, my name is Hardeep and welcome back to my YouTube channel. And today we are talking about Linux file permissions. So before I get started, I just wanted to show you that I have changed the structure of the repository. If you get inside this repository, you'll be able to see it kind of now table of contents, links to each GitHub uh, markdown file as well as links to the videos. Some of the video links don't work yet. For example, recording it today, it'll work after I'm done uploading. This one is for future, but won't take longer. I'll get started with Linux file permissions and ownership. So, to understand Linux file permissions, there are three things which are very important. Which is it starts with read, write, and execute. So these are called mandatory access controls or MAC kind of permissions. If you are following my videos, then you should have multipass running and you should have a machine running named Learn Linux. This is how you can kind of just run a command multipass shell. In If you are not sure how to do it, I would say go back in getting started and follow these first three videos and you will know where should you go and how you can have your VM running. Now, getting back to mandatory access control or the Linux file permissions, which is read, execute, and write, the way they are represented is U, G, and O. U is for users, G is for group, O is for others. So Linux divides permissions for file owner, for people who are part of the same group as the owner of the file, and others who are not member of a group, right? So that is third category, others. Now, how do you see permissions? You can run lsl to see the permissions. Well, let's get into Unix shell and we do lsl. We see some outputs here. And excuse me, I wanted to remove the files that I created for testing. I will remove uh, all these, and now this is how your system should be if you created a new virtual machine, right? So you log in and you run lsl, and the output is it shows something like total 8, but then it says d is for directory. Okay, we'll talk about this one later. There'll be a lesson on different file types. So ignore the first one. Next few are the permissions. R is for read, W is for write, X is for execute, right? So if we do it like this, N is to show kind of number for UID. And if you want to see another one, so let's say snap. Now the difference with that command is you see something like this 700, and here you see the permissions too. So the stat command will talk about this as well later, but it shows you Unix permissions in a different format, in a numeric format, right? So anyways, going back, how do you change permissions? Let's say you want to add permissions for a user. You want to add execute permission, right? Let's say we have a file named file.txt. Let's create it, right? Let's create and see what this file is. File.txt, a file got created. It has read write permission for the owner. So first three bits. So very first one is file type. We'll talk about this later, but first three bits are for owner. Second three bits are reserved for the group, and third three bits are reserved for others. I want to show you something really nice. I have referenced it in my documentation too. If you scroll down, and the second link, this is a document written by another gentleman, Brosco. But if you scroll down below, he has explained it really well. So file type, user, group, and others. This is how kind of you need to read it. First bit is for type, second till uh, fourth bit, right? They are for user, then fifth, sixth, and seventh is for group, eighth, ninth, tenth. Those three are for others, right? So coming back to our shell, we were seeing user has a read write access to this file, and this is the owner, this is the group. So in the output, very first field, if you do lsl long listing, very first is file, then owner has read write permission. Who is the owner? This field, it says Ubuntu is the owner, and then next three are read write for group. This field is group, and this is Ubuntu. Ubuntu is the group owner for this file, and it has read write access too. And the last one is others. Others don't have write access to it. So if somebody comes into this directory, try to read it, they'll be able to read even if they are not part of Ubuntu group. Uh, if if any other user comes in, and if they are allowed to get into this directory, by default Unix kind of tightly controls the permissions of home directories. So other users cannot get into this directory or the home directory. If I say pwd, you can see it is home Ubuntu, because it is the home directory of this user, right? Others cannot get inside, they cannot read it. But anyways, what I'm trying to say is, if this file was lying somewhere where others had access to get into, for example in tmp, let's say if we do touch file, and now if we do file, you can see it has permissions. And if we look at the temp, you can see temp is kind of wide open for almost everyone, right? That's why temp is not a safe location to kind of store your files. Anyways, temp get wiped too. Getting back to what I was showing you earlier. Now you understand the permissions. You want to give permission to, let's say, user. You want to add execute permission to a file, right? So if you do this, what you notice here versus here is there is X added. This fourth bit is an X getting added here, right? That's what I said, user add permission. So plus is working to add permissions, right? If I say user minus and then do LSL, you can see X is gone, right? So now if I say group plus X, you can see that thing X is here. Earlier it was not there, right? Similar story, you can remove permissions like this. Then for others, you can do similar thing. You can do others. Now, if you see now, others have permission to even execute this file, right? And another thing you might notice, the newer Linux distributions, they show a different color of the file if it has execute permissions, right? As soon as I remove execute permissions, you'll see it will show up as normal file. It doesn't show in the green color, right? Anyways, how does it get represented in This was symbolic format that I was talking about: U, G, and O. U for user, G for group, O for others. Numeric format is if you specify 4, that is read. If you say 2, that is write. And if you say 1, that is execute. So I did clear. Let's say we want to work on this file, lsl file, and if I say chmod, now the permissions, first of all, how do we see them in numeric format? If I say stat, then it shows permissions are 664. What is 6? 6 is 4 plus 2, right? And going back to our documentation, it says read is 4, write is 2. So it means read and write, right? So here we can see it in the symbolic format too, read and write. So it says 6, 6, and last is 4. 4 means read, right? So how do we change it? Chmod, let's say I want to make the owner as read only, and I want to keep it for group as read write, and for others I want to remove the permissions, right? So let's see what happened. It changed to read. Earlier it was read write, and execute was missing. For group, read write was there because I gave it 6 when I mentioned, because it was earlier also it was 6, and then I said 0. 0 means remove everything for others, right? So what if I don't specify anything? Let's say I say 7 and file. What permissions it's going to change? Will it change for the user, group, or for others? Let's see. It'll change for the others, because numbers, when you do plus minus, it goes from kind of a right side to left, if you are seeing right in front of you, right? Otherwise calculations go from this side to that side, right? Anyways, so when I said 7, so it added 7 here, made everything else as 0. uh, but one thing that we have not talked about till now is this 0. What is this 0? That is kind of always there, but we have not spoken about. This is a bit that is used for, one is sticky bit, another it could be set UID, set GID. We'll talk about that in a few minutes. But how do you change permissions? Let's say you want to change owner for a file, right? How do you do that? I just copied something. It's not going to work because I don't have this new user, but if I run it, it says invalid user, right? So let's do sudo user add new user. And now if we, I missed S, and there is no file.txt. So file, you can see owner has changed from Ubuntu to new user. Now let's fix it. Chmod 664 file. Huh. See, because this guy is the new owner of the file, Ubuntu cannot even change the permissions. Chown, if I could write it correctly, then I can do chmod, right? So this is how permissions are controlled in Linux. And if we scroll down, here you were able to run chown. You can do chgrp if you want to change the group. So when we ran chown, we could see a new user was created. Let me do it. Sudo user del sudo group add, and let's add this group. And now if we run sudo, before I do that, let's do this file. You can see owner is Ubuntu, group owner is Ubuntu, but if we check now, the group owner is new grp. So lsln, if we do number, you can see this is 1001. We do uh, id for Ubuntu, group is 1000, and user id is 1000, right? So there is a change. It became new group, right? What if I delete the group now, right? I added a group, but group del, what do you think it'll show? If I run it, it shows the number now, right? So what is the fix? I can do, I can change it to, rather than this, I can change it to 1000, right? So now it shows Ubuntu. 1000 is equivalent to Ubuntu. Unix understands the number format actually, rather than understanding the names. How they get converted from number to name, we'll talk about in some upcoming video. But uh, here is how it affects the different permissions. If you see R, that is equivalent to 4, right? If you see W, that is equivalent to 2. So if you have read permissions, you can view the content of file. If it is directory, you can list the content of directory. If you have write permission on a file, you can modify, delete, and rename it. And if you have write permission, you can create, delete, and rename files within the directory. And if you have execute, you can run that file as a script, or you can execute the program. If you have execute permissions, you can do cd and access files inside that. But if you don't have permissions, you will not be able to do cd inside a given directory. So you need to have x on a directory. So let's test it, right? Mkdir test lsld test, right? So you can see here others have access to get inside this directory. That's how it works. Sudo user add new user, sudo su new user, and let's go to that tmp directory, and lsl cd, we created a directory named test, right? So if I do lsld, you can see I'm sitting in temp directory, but if I say touch test, it cannot, because lsld tmp test, it doesn't have write permissions. Okay, so let's exit out of it, and let's get back to different permissions. If I give it write permission, so if I say chmod 777, for others also, basically 7 is read write execute, read write execute, read write execute. If I do lsld again, you can see it shows like this. If we do stat on this directory, you will notice it says 777, and here it shows similar permissions, right? But now if we do sudo su not hyphen to that user which we created, new user, and cd this directory lsld dot. Now if we do touch test, here you can see permission denied. Now it is able to create a file. If you see that file is created by new user, and the new user is the group for it. Anyways, those were the permissions. Now there are some special permissions. This is the first bit that I was talking about in the output, this one, right? So these permissions, when you run lsld on some directories, for example, temp directory, you will see a T there in the output. That T tells you this directory has a sticky bit. So if I say stat tmp, you will see it has number one, you can see, right? So this is a special bit and it has no effect on files. If you try to set sticky bit on file, it doesn't do anything. But if you do it on a directory, only owner of that directory can delete and rename the files inside that particular directory, right? So if somebody want to rename the files or delete the files inside that directory, they are not allowed to do that. Only owner is allowed to kind of make those changes, right? So lsld tmp test, and if we set the permissions chmod 177 lsld tmp test, and you can see there is T now, and let's switch to the user sudo tmp test touch abc mkdir abc d mkdir abcd. Okay, Linux just understand everything is a file, even though directory, even though file, everything is treated as file. abcd is also file, abc is also file. So that's why I am able to run file on this one. I should be able to run file on this one, right? And it says it's a directory, the other one is a file. If I run stat, you see it gives some details. If I do same thing stat on abc, you see no difference. So everything is a file in Linux. If we look at temp test, it has permissions for everyone, which we can confirm using stat, and you can see everyone has full permissions, but it has a sticky bit set. So now let's do sudo and try to rm hyphen. First let's try renaming it. Where are we sitting? Let's not sit in the directory that we are trying to rename. Test2, it says operation not permitted, because even if it has full permissions, it is not able to rename, right? So rm hyphen rf, it is not able to remove even if it has full permissions, right? So you can see there are files, it is not able to remove them. However, it was able to remove files that it owned, abc and test, those are gone, but it's not able to do anything to the files that are owned by Ubuntu user. Let's clean up rmrf in the current directory. Be careful with rmrf. It is forceful. I'm removing everything and I'm removing in current directory only, right? Now let's do sudo su and try to delete it or rename it again, right? Test2 not allowed, rmrf not allowed. If I go to this directory rmrf, and it is allowed, right? So that's the purpose of sticky bit. It ensures that only owner is able to rename or delete. Root is the exception. Root has full power, it can go and delete files. Then there is another permission called set gid. This has permission of 2. So the very first octet in these 4 octets, right? The very first one, if it becomes 2, that means you are setting a GID. If you set a GID on a file, it gets executed with the uh, y- you know group's privilege. Okay, now let's create a touch script.sh lsld lsld script.sh chmod 755. So 755 is making this script executable. Read write execute for the owner, read and execute for others and group, right? So it's a script. What does it do? As of now, nothing, but we can chmod 2755 script. You see it shows S, right? So if we do stat on script, it shows 2755, right? Now, how do you understand these permissions? You need help. You forgot about these, right? So you can run man chmod. This will give you full details about you know uh, what it means when you are writing specific things, right? It also gives you more details about how you can minus, plus, and all that. Anyways, that was just a quick tip in between. And we are talking about group ownership. So if somebody executes this script now, let's say that new user, the one we just created, if that person executes, this script will get executed with the privileges of Ubuntu group, because Ubuntu is the group owner for this script, right? And you can see it shows up very differently. Execute, it was not having the GID set. You can see we added 2 here and color changed, right? So the new terminals in newer Linux distributions are much better at showing the things. Then finally, you have another one, which is a special bit called set UID. If you run this, it is kind of dangerous. You should be very careful with it, because anybody who is running this, even GID is also dangerous. Be very careful when you are setting UID and GID, because if your script has something that it could do, for example, it could delete users, add users, and by mistake you give it a permission, like I was showing, 2755, that script will get executed with the permissions of the group, in this case with the permissions of the owner itself. So if owner is root and you gave it a permission with set UID, that means any normal user will be able to execute that script and it will run as a root. So be very careful. A root is very powerful. Root is the kind of ultimate supreme power in Linux. There are ways to control that also, but will not be diving into that. You If you try to set UID on a directory, it doesn't have any impact, but set GID has an impact. So any files, any directories you create inside the parent directory, they will have same group. So let's kind of see it in action, right? Mkdir test and do it ch mod 2755 or 2777, right? If I do 377, that means directory will have sticky bit also, and it will have GID also, right? So now if I say stat test, You can see it says, here is S and here is T, and in this output also you can see T and S. That tells it has a set GID, and it also has sticky bit, right? Now let's switch to that user and go to temp and cd test any files. If this guy creates now, touch abc lsl, you can see group is ubuntu. And if this guy creates abc, you can see group is ubuntu. That's the result of set gid. Okay, it is inheriting the uh, group ownership. Okay, now let's get out of chmod 0777 test test g minus s test. Now let's see the permissions. We'll try to change and let's see if we can remove the permissions or change the permissions, right? This is 177. Let's try removing it. 0, and we see we have permissions removed. And now let's try with GID, and if we try removing it, it doesn't. Why? Because running command with 0775 will not remove it, because it thinks it is just an octal notation. So you need to use G minus S. Sudo get into tmp test and touch ab, and where is our abc? You can see new file is getting created with its own group. With that, I think I have covered everything that I wanted to talk about. In this, you will also be able to see something special. That something special is how does it by default give permissions as 755. Whenever you create a file, it creates 664, right? So touch, you see it is 6, 6 and 4, and you can see 664. So how does this 664 comes? It comes from a command called umask. So basically it is minusing this number from the total permissions that are getting assigned. I would say read more about it and try changing umask, right? So umask 0. Let's see what is umask looking like. Now it is 0, and if I say this, and now you see it is read write read write read write, right? Umask 2, makes it 644. For if we say 6, and now this guy has no permissions, which is others, right? So if you run lsl, no permissions, right? So that's about it. And I would recommend going through this. There are exercises that will help you understand these permissions. There is also, if you search for umask, it also talks about umask, and it will help you to understand umask better. All right, with that, I'll stop. Thank you everyone for your time, and I'll see you next week. Take care. So your homework is these exercises. Please work on them. We'll meet next week. Bye.